Imagine drifting far above the Milky Way, far beyond the pull of any single star. From here, the galaxy stretches beneath you, like a glowing whirlpool arms of starlight spiraling through the velvet dark. You can see its heart, bright and golden, wrapped in dust and mystery, and its outer reaches fading into a dim, silvery haze. From this height, our entire world, the sun, the planets, and every story ever told are tucked inside one faint arm of light. Hey there, I'm glad you made it tonight. Maybe it's been a long day, and your mind is still spinning a little, just like the galaxy itself. But here, things slow down. The only motion that matters now is the slow, steady turning of 100 billion stars. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'd also love to know where you're listening from and what time it is for you right now. It's always amazing to see where in this galaxy we all are. Now, if you're ready, let's begin. The Milky Way is our cosmic home, but few ever see it as it truly is. To the naked eye, from the ground, it looks like a faint cloud stretched across the night sky. Yet, that mist is a city of stars, hundreds of billions of suns, each with its own planets, its own histories, its own chance at life. From above, it takes the shape of a spiral, about 100,000 light-years across. It turns slowly, one rotation every 230 million years. That means the last time the Sun completed a single orbit around the center, dinosaurs still walked the Earth. The center itself is a glowing core of ancient stars, wrapped around something darker, a supermassive black hole called Sagittarius A*. It doesn't dominate with violence, but with gravity, a silent conductor holding the galaxy's rhythm together. Around it, stars whirl like dancers in a ballroom so vast that each step takes centuries. Farther out, the spiral arms sweep gracefully, bright lanes filled with gas and dust where new stars are born. If you could watch the Milky Way in motion, it would look alive. Its arms would ripple with waves of star formation, like tides moving through light. Clusters ignite, then fade. Clouds collapse, then bloom again. Every flicker, every spark adds to the pattern. It's hard to imagine scale here. The space between stars is so enormous that if the Sun were a single grain of sand, the nearest star would be several kilometers away. Yet, gravity binds them all in one collective swirl. Some astronomers compare galaxies to living organisms constantly feeding, growing, shedding, and renewing. The Milky Way breathes through cycles of creation and destruction. It draws in gas from the intergalactic medium, forming new generations of stars, while older ones burn out and scatter their ashes back into the void. Every element in your body, carbon, oxygen, iron, was once part of a star that lived and died within this grand spiral. In a way, the Milky Way isn't just the galaxy we live in, it's the galaxy we're made of. Look closer at its arms, and you'll find structure within structure. There's the Perseus arm, the Scutum Centaurus arm, and tucked quietly between them, the Orion spur, where our sun resides. We sit about 2/3 of the way out from the center, close enough to feel the galactic heartbeat, far enough to see the dark. From this position, when you gaze at the sky on a moonless night, you're looking edge-on through the disk. What appears as a pale river of light is the combined glow of countless suns layered together, their radiance softened by clouds of interstellar dust. That dust doesn't only obscure, it paints. It absorbs blue light and scatters red, giving the galaxy its warm, amber tone. Between those clouds, there are windows, clear patches through which we glimpse star clusters sparkling like frost. Sometimes, faint nebulae glow in pink and violet, remind us that even in darkness, creation continues. If you listen with your imagination, you can almost hear it. The quiet hum of energy, the soft sigh of stars forming from gas, like breath condensing on glass. Scientists think the Milky Way is about 13.6 billion years old, nearly as ancient as the universe itself. It was once a smaller, simpler structure built from the merging of tiny protogalaxies. Each collision added new stars, new elements, and a little more shape to the spiral we see today. Even now, the Milky Way continues to evolve, swallowing smaller galaxies at its fringes. It's a slow feast, taking millions of years, but it never truly stops. Our galaxy is both predator and artist, shaping itself through cosmic encounters. If you were to travel outward from our Sun at the speed of light, you'd need 26,000 years just to reach the center. To cross the entire disk would take 100,000 years. And even then, you'd still be inside a larger structure, a halo of invisible matter stretching far beyond the luminous edge. From the outside, the Milky Way would appear delicate and finite, but in truth it extends into darkness, bound by forces we cannot see. It's humbling to think that everything we know, the sun, the earth, the moonlight spilling through your window right now, all belongs to one thin strand of that spiral. We are small, yes, but not insignificant. Our existence is proof that within this vast pattern, consciousness can arise, look outward, and wonder what lies beyond. The same gravity that holds distant stars in orbit also keeps your feet on the ground. The same atoms forged in ancient supernovae now flow through your veins. The boundary between the cosmos and the self is thinner than we imagine. Sometimes, when you stand beneath a truly dark sky, you can feel it. The galaxy above seems to curve around you, a gentle arch of light embracing the earth. For a moment, you sense both your fragility and your belonging. You are part of that spiral one thought among billions, drifting, shining, fading, and returning. So tonight, as you close your eyes, picture the Milky Way slowly turning, its arms unfurling like the petals of an infinite flower. Every rotation is a breath in the life of the universe. Every star a heartbeat. You too are one of those lights, brief, beautiful, and essential to the whole. Sleep now, knowing that the spiral that holds us will keep turning, quietly, faithfully, long after this night fades. Far out from the bright heart of the Milky Way, beyond the crowded lanes of newborn suns, lies a quieter realm. The light grows thinner here. The air, or what counts as air in the interstellar dark, carries less dust, fewer atoms, and almost no sound. It is a place of endings, where the galaxy itself seems to exhale and slow. Stars here do not blaze with the youthful fury of the core. They burn softly, faintly, like embers in the ashes of a cosmic fire that has been burning for billions of years. If the Milky Way were a living creature, this would be its grey hair, beautiful, delicate, and full of memory. The oldest stars orbit here, their paths tilted and uneven, carrying the signatures of an ancient time when the galaxy was still forming. Many of them are red giants, stars that have swollen with age, their outer layers stretched thin by exhaustion. They glow with a warm, rusty hue, pulsing slowly, their light steady but fragile. These elder suns once looked like ours, bright, white-yellow, full of vigor, but time changes everything. As hydrogen in their cores runs out, they swell and cool, turning their once hot faces into vast spheres of dim fire. In a few billion years, our own sun will join them, shedding its outer layers like petals, leaving behind a tiny, dense remnant no larger than Earth. That remnant, a white dwarf, will shine faintly for trillions of years, cooling so slowly that long after humanity and even Earth are gone, its pale light will still drift through the night. If you could stand on a lonely planet, orbiting one of these elder suns, the sky would be softer, gentler. The star above you would be enormous, filling half the horizon, its surface rippling with convection cells the size of continents. Light would feel warmer, more orange than gold. And you might look up and see other red giants glowing in the distance, slow beacons marking the outer lanes of the Milky Way. These stars are storytellers. Inside them, elements are being forged: carbon, oxygen, and heavier metals atoms that will one day seed new planets and new lives. When a red giant finally exhales its last breath, it sends a cloud of dust into the dark. That dust drifts and cools, joining other clouds until gravity pulls it together again, forming new suns, new worlds. In this way, the edge of the Milky Way is not just a cemetery, it's also a nursery, where endings become beginnings. Between the elder stars lie pockets of near emptiness, regions where the density of matter drops to almost nothing. These zones feel vast and still, but even here, cosmic winds blow streams of particles expelled by dying stars, carrying whispers of light through the void. Over millions of years, these winds sculpt faint, misty shells, planetary nebulae that shimmer in blue, green, and rose. Their colors are ghostly, visible only to telescopes, but their symmetry is haunting perfect spheres, expanding quietly into the cold. Astronomers call this region the galactic halo, though much of it lies unseen. The halo holds some of the oldest known stars, metal, poor, ancient, born before the Milky Way even took shape. Their light is so faint that detecting them requires patience, sometimes decades of observation. But when their signals arrive, they tell us stories from the dawn of time, of hydrogen and helium, of the first fusion fires that turned darkness into light. Each one is a relic, glowing still after more than 13 billion years. Imagine drifting among them now. The spiral arms fade behind you, and the stars thin out until you can count them one by one. You're surrounded by silence so deep it feels endless. Then, out of the black, a single red light appears, a solitary giant star, pulsing in slow rhythm. Its glow reflects off invisible dust grains, painting the space around it in a faint copper haze. There are no planets here, no constellations, no horizon, only that star and you, sharing a moment in eternity. Scientists have found that at these distances, the Milky Way's disk begins to warp. It bends, like a great sheet of light twisting at its edges, as though the galaxy itself were gently breathing. Some say the distortion comes from interactions with smaller galaxies nearby, their gravity tugging at the outer stars. Others think it's caused by dark matter, an invisible hand shaping the cosmic fabric. Whatever the cause, the effect is graceful, almost musical, as if the galaxy were a giant record spinning in the dark, its edge vibrating with unseen rhythm. And yet, despite the silence, this region is never truly still. Stars here continue to move, orbiting the center every few 100 million years. Their slow motion writes invisible calligraphy across the night, arcs that trace the galaxy's history in glowing ink. Occasionally, one of them drifts too close to a passing mass and is flung outward, leaving the Milky Way behind entirely. These exiled suns travel alone through intergalactic space, homeless but still burning. Some will wander for billions of years, lighting the darkness between galaxies like drifting candles. When you think about it, these old stars are not so different from old souls, quiet, patient, content to glow softly while the younger ones burn themselves out. Their existence is a lesson in endurance. They remind us that brilliance isn't only found in youth or speed, but in the steady persistence of time itself. They've seen galaxies collide, elements form, and planets rise and fall. They are the witnesses of creation's slow rhythm, keeping their vigil at the edge of the known world. And maybe, in some way, we carry their memory within us. The iron in your blood, the calcium in your bones, the oxygen you breathe all once lived in stars like these. When they died, they sent those elements into the void. and from that dust, our world was born. You are literally made from the ashes of the Milky Way's elders. Their age flows through your veins, their light flickers behind your eyes. You are both their descendant and their continuation. So as you rest tonight, imagine those ancient suns glowing far beyond the reach of telescopes. Their light has been traveling for eons, crossing the cold and silence to reach you. And as it touches your eyelids, faint and soft, it carries the story of everything that came before the patience of time, the beauty of endings, and the quiet promise that even in the farthest corners of the galaxy, light never truly dies. Sleep well, traveler. The stars at the edge are still watching over you, whispering softly across the ages. They remind you that growing old isn't an end, but a transformation, the steady dimming of one flame that makes room for the next to rise. If you were to leave the Milky Way, entirely sailing outward beyond the spiral arms, past the last wisps of interstellar gas, you would enter something vast and nearly invisible. Astronomers call it the galactic halo, but halo feels too gentle a word for such immensity. It's not a glowing ring or a luminous crown. It's an ocean of darkness, made of particles that barely interact with light at all. And yet, without it, the galaxy as we know it would fly apart. This is the domain of dark matter, the mysterious substance that outweighs everything we can see by more than 5 to 1. No telescope can photograph it, no eye can see it, but its presence is undeniable, revealed only through its pull. The stars at the edge of the Milky Way move far too fast to be bound by the visible matter alone. Something unseen holds them in orbit, an invisible hand cupping the spiral, keeping it from unraveling into the void. Imagine drifting through this region. The familiar glow of the galaxy dims behind you until it becomes a soft, swirling patch of silver in the distance. Around you, there's no starlight, no dust clouds, no planets, and yet there's weight here, gravity so faint you can't feel it, but enough to shape everything. It's like being surrounded by the ghost of a storm, a wind that never touches you but moves the world all the same. Scientists think the halo stretches far beyond what we can measure, perhaps 200,000 light-years from the galactic center, more than twice the visible width of the Milky Way. Within it, scattered like islands in a dark sea, are globular clusters, dense spheres of ancient stars, some nearly as old as the universe itself. Each cluster contains hundreds of thousands of suns packed tightly together, orbiting like bees around a hive. Their light flickers faintly, golden and patient, the last remnants of the galaxy's youth. To peer into a globular cluster is to look back in time. The stars inside are survivors from an era before the Milky Way was fully formed, when gravity was still sculpting chaos into harmony. Their orbits take hundreds of millions of years, tracing slow, graceful ellipses through the halo. When astronomers capture their light, they find it almost pure, untouched by heavier elements. These are the universe's elders, forged in a cosmos that knew only hydrogen and helium. And then there is the matter that no one can see, the dark scaffolding that holds all of this together. Scientists have tried to capture it indirectly, to map its fingerprints on the motion of stars, on the bending of light from distant galaxies. The evidence is everywhere, and yet the thing itself remains elusive. It doesn't emit, absorb, or reflect. Light it simply is, woven into the fabric of the cosmos like threads in invisible silk. Some theories say dark matter could be made of undiscovered particles, others of primordial black holes, or exotic quantum fields that ripple silently through space. When you think about it, the halo is less like a place and more like a presence, a quiet foundation beneath everything else. It's the galaxy's skeleton, unseen but essential. Without it, the Milky Way's arms would drift apart like smoke. Every star, every planet, every grain of dust owes its position to this dark embrace. We are held by something we cannot perceive, and yet it shapes every sunrise and every breath. If you were floating here, you might look back at the Milky Way and feel a strange sense of both separation and connection. The galaxy would hang in the distance like a glowing island in an infinite ocean. Its spiral arms would shimmer faintly, each curve alive with countless suns, while the vast halo around it, your new home, would stretch beyond sight. The boundary between galaxy and universe would blur. You would realize that the Milky Way doesn't end with light. It fades into shadow. There's something poetic about that, the idea that what sustains us is invisible. In the same way that love, memory, or consciousness cannot be weighed or measured, but still shape our lives, dark matter shapes the cosmos. It reminds us that reality is bigger than perception, that the most important forces may work quietly, unseen. Some astronomers describe dark matter as a cosmic whisper, gentle, steady, never shouting, but impossible to ignore. It passes through your body every second, trillions of particles moving like ghosts without touching you, indifferent yet ever present. You are immersed in it right now. You live inside the halo, just as Earth lives inside the galaxy. It surrounds you, embraces you, and continues endlessly beyond your imagination. And though the halo feels empty, it hums with energy. At its edges, the pull of the Milky Way weakens and the universe begins to tug back. The boundary between what belongs to our galaxy and what belongs to the cosmos is not sharp, but gradual, a fading of gravity's voice. Beyond it lies intergalactic space, the realm between galaxies, where light travels for eons before meeting anything else. Yet, even there, the influence of dark matter stretches on, linking the Milky Way to its neighbors in a vast, invisible web that spans the entire universe. From this vantage point, the galaxy looks fragile, like a luminous seashell suspended in the dark. And yet, you know it is strong, held together by a mystery older than light itself. The stars near the core blaze with life, unaware of the unseen guardian encircling them. But here, at the edge, where the visible fades, you can feel it, the quiet gravity of what cannot be known, the calm presence that keeps everything whole. So tonight, if your thoughts begin to drift, imagine yourself floating there weightless, surrounded by silence, the Milky Way glowing faintly in the distance. You are held by invisible arms, carried in the stillness between stars. And as your breathing slows, let that thought comfort you. Even in darkness, there is structure. Even in the unseen, there is care. The universe does not need to be visible to be kind. Far beyond the bright swirl of the Milky Way's arms, where the light grows faint and the temperature drops close to absolute zero, float the oldest travelers in our galaxy. They are the ghosts of ancient stars, silent survivors from an era when the universe itself was still learning to shine. These stars are the fossils of creation born billions of years before our sun, carrying within them the chemical signatures of the cosmos's first breaths. When the Milky Way was young, it wasn't the elegant spiral we know today. It was a rough, uneven cloud of gas and dust, colliding with smaller galaxies, gathering matter like a drifting snowball. In that chaos, the first stars formed massive, unstable, and short-lived. They burned fast, exploded violently, and vanished into supernovae, scattering heavy elements into space. The ghosts we see now are not those fiery ancestors themselves, but their descendants, the second generation, forged from the ashes of the first. Astronomers find them by searching for stars with almost no metals in their composition. In astronomy, metals means everything heavier than helium elements like carbon, oxygen, and iron. The early universe was almost pure hydrogen and helium. So when scientists discover a star made mostly of those two elements, with only a trace of anything else, They know they're looking at something ancient, something that remembers a time before Earth, before the Sun, before even the spiral shape of the Milky Way existed. One of these stars, called SMSS J031300, 36,670,839.3, lies deep in the galactic halo. It is thought to be over 13 billion years old, one of the first ever born. Its light is so faint that telescopes must stare for days just to catch enough of it to measure. When that light finally reaches us, it carries messages from a time when the universe was still dark, before galaxies had fully formed. It's like hearing the last echoes of the Big Bang humming through a cosmic cave. If you could stand near such a star on some cold, forgotten planet that somehow orbits it, you would see a sky unlike any other. The stars around you would be sparse, each separated by unimaginable distances. The Milky Way's spiral arms would be a faint smudge, barely visible on the horizon. The star itself would burn with a pale, steady light, not brilliant, not fiery, but ancient, almost tired. You'd feel as though time had slowed, as though you were standing outside history, watching the galaxy spin from afar. These old stars are not arranged neatly in the disk like younger ones. They wander in the halo, moving in elongated, tilted orbits, remnants of the Milky Way's earliest mergers. Some belong to ancient dwarf galaxies that were devoured long ago. Their stars, torn free, now drift as lonely exiles. Others are part of globular clusters, tight, glowing spheres that orbit like satellites, each one a microcosm of the early universe. Astronomers sometimes call these ancient stars stellar archaeologists. Their chemical fingerprints tell the story of the universe's youth. A little extra carbon here, a trace of magnesium there, each one a clue to the kinds of explosions that seeded the cosmos with matter. By studying them, scientists can reconstruct how the Milky Way grew from a patch of gas into a grand spiral. Every old star is a time capsule, holding within its light the secrets of cosmic evolution. But beyond the science, there's a quiet poetry to them. They remind us that nothing truly disappears. The first light to ever exist still echoes in the background radiation of the universe. The atoms from the first stars still flow through our veins. The oldest stars still shine, faintly but faithfully, marking the path from what was to what is. They are memory itself, written in hydrogen and starlight. Many of these stellar ghosts have no planets, no companions, nothing to orbit but the center of the galaxy itself. They drift for eons, untouched by time, each orbit taking hundreds of millions of years. Some will eventually be pulled toward the galactic core, where they'll spiral into the dark heart of Sagittarius A*, vanishing into the black hole's quiet gravity. Others will escape entirely, cast outward by gravitational tides, leaving the Milky Way behind to wander intergalactic space, tiny embers fading into infinity. And yet, even as they fade, they leave behind something lasting. The elements forged in their cores are the ingredients of life. When these stars finally die, their ashes scatter across space, becoming part of future nebulae, future suns, and future worlds. The oxygen you breathe, the calcium in your bones, the gold in your jewelry, all were born from the hearts of long-dead stars. You are, in every sense, the heir of their fire. When you look at the night sky, every point of light is a message from the past. Some stars are young, their light just beginning its journey. Others are ancient, their glow having traveled for tens of thousands of years to reach your eyes. And among them, hidden in the faintest glimmers, are the ghosts, the ones that watched the first galaxies form, that saw the universe before it had color, before it had dust, before it had us. To gaze at them is to look into your own origins. Their patience, their endurance, their quiet persistence are the same forces that shaped you. They teach us that even after 1 billion years, light still finds its way. No matter how far it travels, no matter how dim it becomes, it carries memory, it carries presence. So tonight, as you drift towards sleep, imagine yourself floating among those ancient stars. There is no sound, no motion, only slow, drifting through the cosmic dark. Each point of light you pass is a relic, older than any dream, older than any word. You are moving through the Milky Way's memory, through the soft glow of everything that has ever been. Let it comfort you the idea that even after all these ages, the universe remembers. The ghosts of ancient stars still shine, still whisper, still hold the galaxy together with their faint light. And somewhere, far beyond even them, new stars are already being born, their fires fed by the dust of the dead. The galaxy never truly forgets. It only transforms, endlessly recycling its light into new forms, new stories, new lives. And tonight, as your eyes close, you are part of that story, the newest spark in an ancient sea of ghosts. If you could peel away all the stars, dust, and gas from the Milky Way, you'd be left with something invisible, an immense, silent ocean of dark matter surrounding and cradling everything we can see. It does not glow, it does not reflect, yet its presence is unmistakable. The entire galaxy floats in it, like a luminous jellyfish suspended in a deep, unseen current. Scientists call this mysterious substance dark matter, but the name doesn't do it justice. It is not darkness in the way we understand it. It is something deeper, something beyond perception, an invisible structure that holds the universe together. The existence of dark matter was discovered not through sight, but through motion. Astronomers noticed that the stars at the edges of galaxies were moving too fast. According to the visible mass, they should have been flung away into space, escaping gravity's grasp, but they stayed, locked in orbit. Something unseen was anchoring them, exerting a gravitational pull far stronger than all the luminous matter combined. That hidden mass, cold, silent, and everywhere, was named dark matter. Our Milky Way is wrapped in a halo of this invisible substance that stretches hundreds of thousands of light years beyond the edge of its visible disk. It outweighs all the stars, planets, and nebulae, combined by a factor of 5 or 6. Without it, the galaxy would unravel, its spiral arms scattering like petals in the wind. You, me, the sun, the earth, all of it would drift apart into the void. The sea of dark matter is what keeps the Milky Way whole. Imagine drifting through this sea. There's no light, no temperature, no resistance, only a quiet pull everywhere at once. You move through it the way a fish moves through water it cannot see. Every galaxy swims in this same invisible ocean. They do not sit still. They drift and swirl along the dark currents, forming clusters, filaments, and walls that stretch across the universe. From far enough away, the cosmos looks like lace, made of light, bright threads of galaxies, woven through the black, with vast voids in between. Those luminous threads trace the shape of dark matter, revealing its structure like dust floating in sunlight. Scientists have mapped this cosmic web using gravitational lensing, the way massive objects bend light around them. The results are breathtaking. Invisible scaffolding, stretching billions of light years, connecting every galaxy, every cluster, every star. In a sense, the Milky Way isn't an isolated island. It's a pearl hanging on an invisible string of dark matter, bound to countless others across the universe. The ocean we drift in has no surface and no shore. No one knows exactly what dark matter is. It might be made of exotic particles, WIMPs, axions, or something even stranger. These particles barely interact with normal matter, passing through your body, your home, and the entire Earth without a trace. Billions of them flow through you every second, unseen, undetected. You are surrounded by this invisible tide at every moment, held inside its current like a leaf resting on still water. Sometimes, I like to think of dark matter not as absence, but as potential, a kind of cosmic empathy. It holds everything together without demanding to be seen. It is the quiet caretaker of creation, the structure that allows beauty to exist. Without it, there would be no galaxies, no stars, no light to guide travelers home. Even the breath you take right now exists because this invisible sea keeps our galaxy stable, gently turning, generation after generation. If you could see the Milky Way as it truly is, you'd realize that the stars are only the surface like foam on the crest of a vast, unseen wave. Beneath them lies the true mass, the invisible body of the galaxy, ancient and silent. The motions of every star, even our sun, are dictated by this hidden landscape. When you look up at the night sky, you're really looking at the faint ripples dancing atop an enormous cosmic ocean. Astronomers have tried to capture this darkness, building underground detectors buried deep beneath mountains or under Antarctic ice. They wait for a single particle to collide with an atom, to whisper its presence through a flicker of energy. So far, the silence endures. But that silence is not emptiness. It's a promise, a mystery waiting to be understood. The absence of evidence is not the absence of being. Sometimes, when the night is very still, I imagine what it would feel like to float through that dark sea. There would be no sound, no color, no sense of direction. Yet, you'd feel its pull everywhere. The same gravity that holds galaxies together would cradle you too. You'd realize that this darkness is not your enemy. It is the foundation beneath your feet, the unseen rhythm that guides every orbit and heartbeat. Every atom of your body, every particle of your soul has moved through this ocean since the beginning of time. When you were born, when the first stars ignited, when galaxies collided and danced, the sea of dark matter was already there, steady, ancient, waiting. It's a comforting thought, really, that everything we love floats together in the same invisible tide. As you close your eyes tonight, imagine yourself adrift in that vastness. There is no danger there, no chaos, only stillness. You're surrounded by a dark serenity that has existed since the dawn of time. It holds you the way it holds the stars, softly, without judgment, without demand. You are not separate from the galaxy. You are one of its ripples, one heartbeat in its eternal sea. And though you may never see it, the dark matter will always be there, steady, gentle, infinite. It doesn't ask to be known. It only asks that we keep turning, shining, breathing, and remembering that sometimes the most powerful things in the universe are the ones we cannot see. Orbiting quietly around the Milky Way are dozens of small, faint galaxies, tiny companions known as satellite galaxies. They are like the distant relatives of a vast cosmic family, circling the grand spiral without drawing much attention. Most are so dim that they weren't even discovered until recently. They shine with just a few hundred or thousand stars each, mere sparks compared to the Milky Way's hundreds of billions. Yet, they are precious, for they hold the ancient secrets of our galaxy's formation memories written in dim starlight. Astronomers sometimes call them the forgotten satellites because they are so easily overlooked. They drift at the edge of the galactic halo, orbiting slowly, often pulled and distorted by the Milky Way's immense gravity. Some are being torn apart right now, their stars stretched into long, ghostly streams that eventually merge with our galaxy. Others remain intact, quietly orbiting like patient shadows. The two most famous of these are the Large and Small Magellanic Clouds, visible from the southern hemisphere as faint, glowing smudges of light. They've been recorded by travelers and astronomers for centuries, but only modern science revealed what they truly are. Two dwarf galaxies dancing around our own. They are close enough that their gravity tugs at our spiral arms, shaping waves and ripples in the Milky Way's disk. The story of the clouds is a slow waltz of attraction and surrender, a dance that will one day end in collision. If you could hover above the Milky Way and watch for a few billion years, you'd see a mesmerizing ballet. Dozens of these small galaxies orbit in long, looping paths, like fireflies caught in a great vortex. Some drift closer and closer until tidal forces shred them apart. Their stars, once bound in tight clusters, are flung into the galactic halo, becoming part of our own starlit sea. It's through this process that the Milky Way grows, not by constant creation, but by quiet consumption, absorbing its smaller neighbors over cosmic time. Astronomers have found evidence of these past meals. In the halo, there are long trails of stars, faint ribbons of light that curve across the sky. They are the remains of galaxies long devoured. One of the most famous is the Sagittarius dwarf galaxy, which is currently being pulled apart by our gravity. Its stars wrap around the Milky Way like a silver scar, marking the path of its destruction. Each of those stars is now part of us, shining silently in our outer halo. These forgotten satellites are not merely victims, they are architects of change. Their gravitational pulls influence the structure of the Milky Way's disk, creating warps and oscillations. Their gas feeds new generations of stars. When they collide or merge, they bring fresh material, new dust, new elements, and new orbits, revitalizing our galaxy's evolution. Even in their smallness, they leave enormous impact, reshaping the spiral arms with each encounter. There's something deeply human about them. They remind us of forgotten stories, quiet contributors to something much larger, their light faint but enduring. If the Milky Way is a grand symphony of light, these dwarfs are its background notes, subtle, often unnoticed, but essential to the harmony. Without them, our galaxy's history would be incomplete. The smallest of these satellites are almost invisible. Some, like Segway 1 and Boots 2, contain fewer than 1,000 stars. Their combined brightness is weaker than a single bright supergiant. Yet, their gravity holds them together in delicate balance, orbiting the Milky Way like whispers in the void. They are the faintest galaxies ever found, so dim that astronomers discovered them only by their gravitational fingerprints, the way their mass subtly bends light or pulls at nearby stars. These tiny galaxies are time capsules. Many are ancient. Their stars formed shortly after the Big Bang. They have remained mostly unchanged for over 13 billion years, fossil records of the early universe. Studying them is like reading the diary of creation itself. Inside them, astronomers find the simplest chemical recipes: hydrogen, helium, and traces of heavier elements forged in the first supernovae. Every atom within them is a memory of a time when the cosmos was still young and wild. If you were to visit one of these dwarf galaxies, the sky would look strange and lonely. You might see just a handful of bright stars scattered across the heavens, with the Milky Way's spiral glowing far away, filling half the horizon. It would feel like standing on the outskirts of eternity, isolated, yet profoundly connected to something greater. The faint light around you would be the combined glow of stars so old they have forgotten their beginnings. Sometimes I think of these small galaxies as the galaxy's dreams, fragments of its imagination floating around the edges of awareness. They orbit slowly, drifting through time, whispering stories of formation, loss, and rebirth. Though we rarely notice them, they continue their ancient paths, steady as ever, loyal to the gravitational song that binds them. The Milky Way has likely devoured dozens, perhaps hundreds, of these companions over its lifetime. Each one adds its voice to the chorus, enriching the galaxy's story. Even the stars you see tonight may once have belonged to another galaxy, long vanished, its identity absorbed into ours. The night sky is a mosaic of migrations, a patchwork quilt of cosmic ancestry. As you drift towards sleep, imagine those tiny galaxies circling in the far dark. Picture them as sparks around a campfire, faint but constant, orbiting through the silence. Some fall inward, surrendering their light to the spiral. Others keep their distance, guardians of the edge. Together, they form the invisible perimeter of our home, defining its boundaries not with walls, but with motion. The forgotten satellites remind us that even the smallest lights matter. Their glow may be faint, their numbers few, but without them, the galaxy would lose its depth, its texture, its quiet poetry. Every orbit they complete adds another measure to the song of the Milky Way, a song still being written, note by note, in the endless night. If you look up from the southern half of the Earth on a clear, moonless night, you might see two faint, misty patches of light hanging near the Milky Way. They look like pieces of the galaxy that somehow drifted loose, delicate, pale, and softly glowing. These are the large and small Magellanic Clouds, our nearest galactic neighbors. And they are far more than passing clouds of stars. They are living companions of the Milky Way, locked with us in an ancient dance of gravity that has lasted for billions of years. The Magellanic Clouds are dwarf galaxies smaller, lighter, and far less structured than our own. The Large Magellanic Cloud, or LMC, is about 1/10 the mass of the Milky Way, while the Small Magellanic Cloud, or SMC, is roughly 1/5 of that. Each one is filled with hundreds of millions of stars, vast nebulae, and regions where new suns are still being born. The two clouds orbit each other while also orbiting the Milky Way, their paths twisting like ribbons through the darkness. Together, they form one of the most intricate gravitational choreographies in the known universe. Astronomers believe that billions of years ago, the Magellanic Clouds may have been independent galaxies, but as they ventured too close to our spiral giant, the Milky Way's gravity caught them in its embrace. Now, they are both bound and battered by it, pulled, stretched, and reshaped with each orbit. Their outer layers are being slowly stripped away, creating long trails of gas and stars known as tidal streams. These trails form a faint bridge between the two clouds and extend even farther toward the Milky Way, like strands of silk drawn by invisible hands. If you could speed up time and watch from above, you'd see the three galaxies, Milky Way, LMC, and SMC, spiraling around one another in slow, fluid motion. Each tug, each twist, reshapes them slightly. Over eons, gravity weaves their paths into elegant loops, like dancers exchanging steps in a silent waltz. The Milky Way, though massive, isn't immune to their pull. The clouds create ripples in its spiral arms and waves through its gas disk, a kind of galactic tide that ebbs and flows over millions of years. These interactions aren't just beautiful, they're creative. When the clouds pass near the Milky Way, their gravitational encounters compress clouds of gas, triggering new bursts of star formation. The most famous of these nurseries is the Tarantula Nebula, located in the Large Magellanic Cloud. It is one of the most active star-forming regions in the nearby universe, glowing with hot blue stars and sculpted pillars of dust. Within it, clusters of newborn suns blaze with fierce energy, lighting up the nebula like lanterns in the dark. It's a living symbol of the creativity hidden in cosmic collisions, proof that destruction and creation are often two sides of the same story. The Magellanic Clouds also leave behind trails rich in hydrogen gas, what astronomers call the Magellanic Stream. This stream stretches over 600,000 light-years across space, wrapping partially around the Milky Way like a gauzy ribbon. Though invisible to the naked eye, radio telescopes can trace it as it drifts and curls through the galactic halo. It's a cosmic footprint of the clouds' long journey, marking where they've been and where they're going. And where they're going is toward us. In a few billion years, Simulations suggest the Large Magellanic Cloud will collide with the Milky Way, but this will not be a violent crash like we imagine on Earth. It will be slow, majestic, and silent. The two galaxies will merge, their stars passing through one another like ghosts, barely colliding but profoundly reshaping both. The Milky Way's spiral arms will warp and stretch. New clusters will form. The halo will thicken. Our galaxy will grow, absorbing the light of its companions into its own. For now, though, the clouds remain at a graceful distance, hovering on the galaxy's southern edge. Sailors once used them to navigate the open seas. Ancient astronomers mistook them for clouds of vapor or celestial smoke. But even then, their faint glow stirred imagination, the sense that the heavens themselves were alive and breathing. Today, when we look at them, we're seeing a slow-motion story that began before humanity existed and will continue long after we are gone. If you could drift among the Magellanic Clouds, you'd find them both familiar and strange. Their stars would seem scattered, irregular, as though a painter had brushed them across the canvas of space with gentle randomness. You'd see glowing nebulae, faint dust lanes, and the quiet hum of starbirth echoing through the void. Between the two clouds, streams of gas would shimmer faintly, caught in the gravitational tug-of-war between their twin centers. The silence would be absolute, but the motion would be endless, each atom pulled by invisible tides that shape the future of galaxies. There's a serenity to this cosmic relationship, a rhythm that mirrors the tides of the sea. The galaxies draw close, drift apart, and return again, each movement guided by gravity's soft command. And though they may seem distant, their influence reaches us here on Earth. The waves they send through the Milky Way ripple outward, subtly changing the orbits of stars, the distribution of gas, even the structure of our spiral arms. We live within the music they make. As you lie in the dark tonight, imagine that quiet dance continuing overhead. The Magellanic Clouds drift across the southern sky, their light crossing 160,000 years of space to reach your eyes. You are seeing them as they were before the dawn of human civilization, before the first spark of fire on Earth. They are your neighbors in the cosmic ocean, moving in rhythm with you, connected by the same gravitational heartbeat. And one night, far in the future, when the Magellanic Clouds finally merge with the Milky Way, their stars will scatter among ours, their light becoming part of the same river that flows through the night sky. They will no longer be separate or forgotten, they will be home. If you could look at the Milky Way, not with your eyes, but with instruments that see faint starlight spread thin across the sky, you'd discover something astonishing. The galaxy is surrounded by rivers of stars, long, shimmering threads that wrap around its body like silver ribbons. These are the stellar streams, the ghostly remains of small galaxies and star clusters that were torn apart by gravity and absorbed into our own. They are the fossils of collisions, the silent evidence of a galaxy that has grown by devouring others. Each stream tells a story. Once, it was a coherent system, a small galaxy orbiting the Milky Way, or a compact cluster of stars bound tightly by gravity. Over billions of years, the immense pull of our spiral stretched and unraveled it, scattering its stars into a luminous arc that now loops around the sky. To the human eye, these streams are invisible. Their light is too faint, their stars too spread out. But to sensitive telescopes, they appear like soft brushstrokes painted across the blackness. One of the most famous is the Sagittarius Stream, the debris of the Sagittarius dwarf galaxy currently being shredded by the Milky Way's gravity. It wraps almost completely around the galaxy, forming a looping halo of stars that weaves through the constellations of Sagittarius, Hercules, and Draco. If you could see it in full, it would stretch hundreds of thousands of light years, encircling the Milky Way like a cosmic ribbon. Every point of light in that stream was once part of another galaxy, a home torn apart but never extinguished. Astronomers have mapped dozens of such streams using data from the Gaia Space Observatory, which measures the precise positions and motions of billions of stars. These maps reveal an intricate web of filaments around the Milky Way, faint and delicate as spider silk. Some streams trace neat loops, others are twisted or broken, remnants of ancient collisions that occurred billions of years ago. In these streams, we can read the history of our galaxy, the record of every meal it has ever consumed. If you were to drift through one of these stellar rivers, you might not realize you were in one at all. The stars would seem widely scattered, lonely beacons in the void, but over vast distances, their shared motion would become clear, all moving together, slowly orbiting the Milky Way in unison. There is something deeply haunting about this collective drift. These are stars that once belonged to another home, now wandering forever through a sky that is no longer theirs. Some of these stars are older than the Milky Way's spiral arms. Their orbits cut across the galaxy at strange angles, like memories that no longer fit neatly into the present. The way they move helps scientists reconstruct the Milky Way's gravitational field, showing where invisible masses of dark matter tug and pull. In this way, these ghostly streams don't just tell us where the galaxy has been, they tell us what it's made of. Every galaxy in the universe grows this way. They collide, merge, and consume one another, their stars blending together until their individual identities vanish. Our Milky Way, majestic and serene from afar, is also a survivor of countless such events. Its halo is a graveyard of galaxies long forgotten, their remnants woven invisibly into the whole. The streams that circle it are the echoes of those swallowed lives, glowing faintly against the dark. In the far future, these streams will fade. Their stars will spread even farther, mixing into the galactic background until their distinct shapes disappear. The galaxy will look smooth and complete, its violent past erased by time. But for now, their trails remain visible, threads of remembrance stretched across eternity. To some astronomers, the streams resemble cosmic veins, carrying the lifeblood of the galaxy outward. To others, they are scars, reminders that creation and destruction coexist in perfect harmony. When smaller galaxies fall into the Milky Way, they are not lost. Their stars become part of a larger pattern, part of the endless flow of cosmic renewal. It is a kind of reincarnation, written in starlight, and perhaps that's what makes them so mesmerizing. In their ghostly drift, there is both tragedy and beauty. Each stream is a bridge between worlds, what was and what is, what once belonged elsewhere and now belongs to us all. Their faint arcs across the night are a celestial metaphor for memory itself, fragile, glowing, impossible to hold, yet never fully gone. If you lie under a dark sky and let your imagination stretch, you might picture them overhead, thin rivers of forgotten light, winding through the galaxy, curving between constellations. Their stars move too slowly for us to see, but they are always in motion, always returning, always circling the invisible heart that binds us all together. In a way, the stars of those ancient galaxies have become our neighbors. Their light now mingles with ours, their gravity shapes our sky. We are built in part from their remnants, atoms forged in alien suns, now woven into the same galactic fabric. Every breath you take, every beat of your heart, is sustained by a cosmos that remembers everything, even the things it has destroyed. As you drift towards sleep, think of those stellar streams flowing silently above you. They are not lost, they are simply transformed, moving in slow procession around a center that holds them in peace. They are the galaxy's sigh, its memory, its poetry. And within that vast, endless motion, you too are carried one small consciousness adrift in the same current of eternity. there is a place, far beyond the bright spiral arms and the quiet halo of stars, where the Milky Way's pull begins to weaken. Out here, the galaxy's rhythm slows, its light grows pale, the familiar gravity that binds suns and planets starts to thin, stretching into the greater darkness between galaxies. This is the edge where gravity fades, the soft boundary between belonging and drifting away. If you were to journey outward from Earth, passing the Sun, the other stars, and the last dim clusters that orbit in the halo, you'd eventually cross an invisible line. Inside this line, the Milky Way reigns. Outside it, the universe takes over. Astronomers call this distance the galactic boundary, the point where the gravity of the Milky Way and the pull of the surrounding cosmos balance each other. It is not sharp or sudden, but gradual, like twilight fading into night. The stars that wander here live in delicate balance. Some remain loyal to the galaxy, circling in slow, wide orbits that take billions of years to complete. Others have ventured too far, their paths stretched thin until gravity finally releases them. These are the intergalactic travelers, stars that slip quietly away from home. They continue onward, untethered, into the vast emptiness between galaxies, a place so cold and silent that even light seems reluctant to go there. Imagine yourself standing on a small planet, orbiting one of those exiled stars. You would see the Milky Way rising in the distance, not as a sky-spanning river of light, but as a faint oval, delicate, distant, almost fragile. Around you, there would be darkness deeper than anything you've ever known. The nearest other star might be millions of light years away. You'd be surrounded not by a sky full of constellations, but by isolation, one tiny world illuminated by a single, lonely Sunday. And yet, even here, there is motion. Gravity, though faint, never truly disappears. It stretches infinitely, growing weaker, but never gone. The Milky Way's influence can still be felt as a whisper, a subtle tug, guiding matter, shaping orbits, holding onto fragments of what once belonged to it. The galaxy's edge is not an end, but a blending. Its gravity merges with that of other galaxies, their invisible hands touching in the dark, creating the delicate fabric of the local group, our neighborhood of galaxies, drifting together through space. Among the Milky Way's nearest neighbors is the Andromeda Galaxy, massive and luminous, gliding toward us through the void. Though it lies over 2 million light-years away, its gravity already interacts with ours, distorting the outer edges of both galaxies. Every faint pull, every invisible ripple, sets the stage for a collision that will happen billions of years from now. When it comes, the two spirals will merge, and their edges where gravity once faded will become one. The borders of each will dissolve, forming a new, larger galaxy, an elegant union written in slow motion. At the present edge, though, things are quieter. Here, the Milky Way's gas runs thin. Stars are sparse, and interstellar clouds become transparent. The dust that once painted nebulae and star nurseries now disappears, leaving only the raw, clean geometry of starlight. The radiation from the galaxy fades into the background hum of the universe, the faint echo of the Big Bang, still vibrating softly across all of space. It's a place of transition, a liminal zone between creation and stillness. Astronomers sometimes detect faint hydrogen gas out here, drifting in long filaments. These are the outermost traces of the Milky Way's breath, the last wisps of material escaping its pull. Some of it will fall back eventually, feeding future generations of stars. Some will continue outward, joining the intergalactic medium, a thin soup of atoms that fills the spaces between galaxies. Even the galaxy exhales, it seems, releasing what it no longer needs, making room for what comes next. If you could listen to this region not with ears, but with instruments tuned to gravity, you'd hear almost nothing. The deep hum of motion that fills the galactic core would fade into silence. Yet, in that silence lies profound serenity. This is where the Milky Way lets go, where it hands its stars to the cosmos and accepts that not everything can be held forever. It's the ultimate act of cosmic grace, release, and still beauty lingers. Even a single star here shines like a miracle. Against the vast emptiness, one point of light carries the memory of a galaxy, a reminder that belonging is not erased by distance. The light of that star may take hundreds of millions of years to reach another observer, yet it travels faithfully, carrying within it the quiet story of where it came from. The edge of the Milky Way is also a mirror of our own boundaries. Just as the galaxy cannot hold everything it creates, neither can we. Over time, things drift away: memories, people, dreams. They move beyond our gravity, fading into their own quiet existence. But like the stars that leave the Milky Way, they still carry a part of us, still orbit invisibly in the wider universe of what once was. So tonight, imagine yourself hovering at the very rim of the galaxy. The Milky Way glows behind you, a river of light curving across eternity. Ahead of you lies the infinite sea, black, silent, waiting. You are standing at the meeting point of gravity and freedom, of belonging and release. And in that stillness, you can feel the truth the galaxy has always known, that even when light fades, connection remains. Out here, at the edge where gravity fades, everything slows. Even thought seems to drift. The stars move like memories across the dark, patient and eternal. You are part of them, carried gently between the pull of the past and the promise of the endless beyond. Beyond the crowded spiral arms and the luminous core, there lies a region of silence, the vast interstellar desert of the Milky Way. It is a place where the glittering density of stars fades into emptiness, where light itself seems to hesitate before crossing. Out here, space stretches wide and quiet, and the grand symphony of the galaxy becomes a whisper. It is not a desert of sand or wind, but of distance immense, endless distance, where even the faintest grain of dust is precious. If the center of the galaxy is a bustling city of stars, this region is its outer wilderness, empty plains between glowing settlements. The stars here are few and far apart, separated by light years of cold nothingness. Even the gas and dust that fill much of the Milky Way thin out, leaving pockets so empty that a single hydrogen atom may drift for miles before meeting another. Yet, this emptiness is not lifeless. It's simply resting, waiting. Astronomers call these areas interarm regions, the spaces between the Milky Way's bright spiral arms. They are the quiet corridors of the galaxy, and while they may appear barren, they play a vital role in its breathing rhythm. Streams of cold hydrogen drift through them, feeding the spiral arms where new stars are born. Like an ocean current between reefs, this invisible flow connects the galaxy's luminous islands, maintaining balance in a cosmos of extremes. If you could float here, the sky around you would look strangely sparse. You might see only a few stars, small, sharp points of light, scattered across infinite black. Behind you, the Milky Way would hang like a pale mist, stretched thin against the dark. There would be no sound, no heat, only the gentle pulse of radiation from the galaxy far away. It would feel like standing on the edge of time itself. Yet even in this apparent desolation, hidden wonders dwell. There are rogue planets, worlds without suns, drifting endlessly through the dark. They were once parts of solar systems, perhaps flung away by gravitational chaos, or born from clouds that never ignited into stars. Now they wander alone, radiating faint heat from their cores, carrying frozen oceans and buried memories of light. Some may still harbor atmospheres, warmed only by the decay of their own elements. In the vast interstellar desert, even a lone planet becomes a small miracle of endurance. Among the dustless voids also move brown dwarfs, the failed stars of the galaxy. Too massive to be planets, but too small to ignite into true stars. They glow faintly in infrared, like cooling embers in the cosmic night. If you passed near one, you'd see its dim, violet hue, soft, unassuming, but still alive. Around some of them, tiny moons orbit silently, following paths no one will ever see. There are also nebula ghosts, faint clouds of gas expanding from long-dead stars. Each one is the final breath of a sun that once burned brightly, now diffused into the surrounding void. These delicate structures drift through the darkness like veils of color blue, pink, and green remnants of lives that ended billions of years ago. In their fading light, you can almost feel the echo of the stars they once were. And between it all, magnetic fields hum, weak but constant, threading the void with invisible lines of force. They guide particles, shape gas, and influence the dance of cosmic rays that sweep across space like unseen winds. Though we cannot feel them, these magnetic currents are the unseen architecture of the desert, the scaffolding that gives even emptiness a kind of structure. It's strange to think that inside this desolation, everything still moves. Even in apparent stillness, stars drift, gases flow, and gravity reaches outward in endless patience. The interstellar desert is not absence, it's possibility. It is the quiet moment between breaths, the pause before creation. When enough gas gathers in these empty regions, gravity takes over, pulling it together into new clouds, new suns, new worlds. The desert is where the seeds of the next galaxies rest, waiting for time to awaken them. If you listen not with ears, but with imagination, you can almost hear the hum of cosmic background radiation, the faint afterglow of the Big Bang. It fills every corner of the desert equally, a soft hiss of existence left behind by the birth of everything. It reminds us that even in the deepest silence, the universe is still speaking, still alive. To astronomers, this vastness is both humbling and comforting. It means that our galaxy is not a closed system, but part of something larger. Its edges are porous, breathing in and out through these empty corridors. The light from distant galaxies crosses the same space, traveling billions of years without interruption, passing through this transparent calm on its way to us. The interstellar desert is the crossroads of the cosmos, a place where all things eventually pass. Sometimes, when I think about it, I imagine the desert as a metaphor for our own inner spaces. We, too, have quiet distances between the bright constellations of our thoughts. And maybe that's where clarity hides, in the stillness between the stars, in the pause between heartbeats. Just as the galaxy needs its silent spaces to breathe, so do we. So tonight, as you drift towards sleep, imagine yourself gliding through that desert. There is no fear, no loneliness, only peace. You are surrounded by the quiet fullness of space, by the patient pulse of light that travels forever. In the infinite dark, you are not lost. You are resting in the heartbeat of the galaxy itself, floating between moments of creation. The interstellar desert may seem empty, but it holds everything that will ever be. It is the cradle of what's next, the soft breath of the Milky Way before it dreams again. Every galaxy has its wanderers, stars without a home, roaming freely through the dark between worlds. These are the wandering suns of the Milky Way, solitary beacons that drift through space with no planets, no companions, and no allegiance to any star system. They are orphans of cosmic gravity, ejected from their birthplaces by the violent interactions of galaxies, black holes, and supernovae. And though they are lost to us, they still shine, carrying the memory of the places they once belonged to. Astronomers call them rogue stars or hypervelocity stars, and they move with astonishing speed, millions of miles per hour, fast enough to escape the Milky Way's gravity entirely. Some were thrown out after close encounters with the supermassive black hole at the galaxy's center. When a binary pair of stars wanders too near, one is captured, while the other is slingshotted outward at tremendous velocity, sent hurtling toward intergalactic space. Others are the survivors of explosions supernovae that destroyed their companions and propelled them into the void. Whatever their origin, their journey is eternal. If you could see one of these stars up close, it would look almost ordinary, a warm, steady light floating alone against the black. But its isolation tells a different story. Around it, there are no neighboring suns, no familiar constellations. It burns alone, with no planets to orbit it, no moons to reflect its glow. Its light travels outward endlessly, illuminating nothing, touching no one, until it fades into infinity. And yet, in its silence, there is dignity, a kind of cosmic courage in continuing to shine, even when there is no one left to see. Imagine traveling alongside one. You drift through the dark, beside a single point of light, a small sphere of fire suspended in the endless sea. The galaxy would be behind you, glowing faintly, like a memory, a pale swirl of silver and blue receding across unimaginable distance. Ahead lies nothing but the deep void, the space between galaxies. The temperature would fall close to absolute zero, and time itself would seem to slow. Yet the star would go on shining, its nuclear heart burning steadily for billions of years, its light marking a trail that no one will ever follow. Astronomers have found that there may be billions of these wandering suns. Some were born in the Milky Way. Others were stolen from smaller galaxies or flung outward during ancient collisions. They populate the galactic halo and beyond, invisible to the naked eye, but traceable through their faint gravitational influence. In the grand scheme, they are like pollen scattered by a cosmic wind, tiny fragments of light spread across the vastness of the universe. There are also slower wanderers stars that drift gently between spiral arms, moving from one region of the Milky Way to another over billions of years. These aren't exiles but pilgrims, crossing the galactic plane in quiet procession. Our own sun may one day join them. As the Milky Way and Andromeda move toward their eventual collision, the gravitational reshuffling could send countless stars adrift. Some will merge into the new galactic core, but others will be cast outward into the darkness, becoming future wanderers, glowing softly for ages untold. It's humbling to realize how easily stars can be displaced. A tiny change in orbit, a passing gravitational wave, or a nearby supernova can alter their course forever. There's no malice in it, just the impartial flow of cosmic mechanics. Yet within that inevitability lies something profoundly human. We too wander. We leave homes, lose our centers, and sometimes drift far from where we began. But like those stars, we carry our light with us, even when we travel alone. Some of these rogue stars are so fast, they may already be leaving the Milky Way, heading into the dark space between galaxies. Once they cross the edge where gravity fades, they will never return. Their light will journey onward for billions of years, crossing the intergalactic medium, perhaps one day brushing past another galaxy far away. To any beings who might exist there, the light of that lonely sun will arrive as a faint, ancient signal, a postcard from a galaxy they'll never see. Scientists think there may even be rogue planetary systems, where one or more planets remain bound to a star as it drifts. Imagine a world like Earth, orbiting such a wandering Sunday. Night after night, its sky would be empty. No constellations, no neighboring stars. Only one bright light would shine. Its own star, distant but faithful. The day would still come and go. The seasons would still turn. But the rest of the universe would remain unseen. Life there would evolve under a single eternal sun, never knowing the galaxy it once belonged to. And yet, even in exile, These stars are part of something larger. Their movement reshapes the gravitational tides between galaxies. Their light contributes to the faint background glow that fills all of space. When we observe the night sky, a small portion of the light we see doesn't come from organized galaxies at all. It comes from wanderers, the accumulated radiance of countless solitary suns. They are the nomads of creation, carrying illumination to the most remote corners of existence. If you close your eyes now, you can almost imagine their path. Each one moves with quiet grace through the infinite dark, unhurried and unafraid. They do not need a galaxy to belong to. They belong to the universe itself. Their light never truly dies. It stretches outward, forever, becoming part of the soft glow between galaxies, part of the background warmth that fills the cosmos. So as you drift towards sleep, think of the wandering suns. They are the embodiment of endurance, of light persisting in solitude. No matter how far they travel, they keep shining. And perhaps, in your own way, so do you. Even when you feel alone in the vastness, your light continues steady, unseen, but deeply real. Because that's what stars do. They shine, not because someone is watching, but because it is their nature to illuminate the dark. As we drift farther outward through the Milky Way, past the last bright clusters and into the quiet dark, we begin to notice something subtle, a soft, nearly invisible radiance that fills the emptiness. It's not the gleam of starlight or the flash of a nebula. It's something older, dimmer, and more patient. Astronomers call it the galactic faint glow, a whisper of light that persists even where no stars can be seen. It is the quiet heartbeat of the outer Milky Way, where matter thins to its final traces but never quite disappears. At first glance, this glow seems like an illusion. To the naked eye, there's nothing there, just blackness, cold and deep. But to sensitive instruments tuned to radio waves, infrared and ultraviolet light, the darkness comes alive. Hydrogen atoms, the simplest and most abundant elements in the universe, emit faint signals as they spin and realign. These emissions form a diffuse halo of light surrounding the galaxy, the ghostly afterglow of its vast stores of gas. Hydrogen is the quiet worker of the cosmos. It doesn't sparkle like a star or blaze like a supernova, but without it, nothing would exist. Every star begins as a cloud of hydrogen atoms collapsing under gravity. Every breath of air, every molecule of water traces its lineage back to this elemental gas. And out here, at the edge of the Milky Way, hydrogen still flows, thin but endless, an ocean of invisibility stretching across hundreds of thousands of light years. When astronomers map these hydrogen clouds using radio telescopes, they find that they move in complex patterns. Some drift along the galactic plane, others swirl in great arcs that reach far above and below the disk. These structures form part of what scientists call the galactic corona, a vast, faint envelope of hot gas that glows softly in X-rays. Though almost impossible to see, this corona contains as much mass as all the visible stars in the galaxy combined. It is the Milky Way's hidden atmosphere, the veil between the known and the unknown. If you could float here, you'd see almost nothing. But if your eyes could sense all wavelengths of light, the view would be breathtaking. You'd see threads of warm hydrogen, glowing in red and pink, pockets of ultraviolet mist from the interaction of cosmic rays, and faint ghostly blue from faraway starlight scattered by dust. It would look like fog lit from within, a diffuse tapestry of color woven from particles too small to touch. You'd realize that darkness, even here, is not empty. It's full of quiet motion. Among these clouds drift the faint remnants of old stars, tiny white dwarfs, neutron stars, and invisible black holes left behind by long-dead suns. They wander slowly through the mist, tracing elliptical paths around the galaxy's invisible border. Occasionally, one passes near a cloud of gas, stirring ripples that travel for light years. The movement is so subtle that it could go unnoticed for 1,000,000 years. Yet, it is enough to keep the halo alive, a breath, a pulse, a rhythm older than life itself. The faint glow is not static. It flickers gently, stirred by supernova shocks from within the Milky Way's disk. When a massive star dies in the inner galaxy, its explosion sends waves of energy rippling outward. Those waves travel through space, compressing and heating the hydrogen clouds that surround us. For a brief time, perhaps a few thousand years, the clouds light up more brightly, like a lantern rekindled by wind. Then, as the shock fades, the light dims again, returning to its near-invisible slumber. To us, it might seem insignificant, but to the galaxy, this cycle is vital. The faint glow is the reservoir of future creation, the raw material from which new stars will one day be born. Over cosmic time, some of this hydrogen will cool and fall inward, joining the Milky Way's spiral arms. There, it will condense into dense clouds, ignite under gravity, and burst into new starlight. Even at the farthest edge, the galaxy is still dreaming of life, quietly preparing for its next generation. It's humbling to realize that we owe our existence to such faint and forgotten things. The same hydrogen atoms glowing invisibly here once floated freely in space before being drawn into a star that became the Sunday. From that sun came Earth, and from Earth came you. The glow you can't see is, in a very real way, your own reflection stretched across space and time. Astronomers sometimes call this background light the sigh of the galaxy. It's a poetic name, but an accurate one. The Milky Way, in its vastness, seems to inhale and exhale through this halo, taking in gas from intergalactic space, releasing energy through its stars, then letting the remnants drift outward again. It's the slow respiration of creation itself, a rhythm that's been pulsing since before the sun existed and will continue long after it dies. If you close your eyes, you can imagine this glow as a soft hum. It isn't loud or dramatic. It doesn't shout its presence. It's the kind of sound you feel more than hear the vibration of existence continuing quietly, patiently, eternally. And so, as you rest tonight, remember that the light around the galaxy never truly ends. Even in the emptiest darkness, something still glows faint, fragile, but unbroken. It is the memory of every star that has ever lived, and the promise of every star yet to come. The faintest glow is the universe reminding us that silence is not absence, and that even the smallest light, though unseen, keeps the night alive. Though the Milky Way appears calm when seen from afar, glowing serenely across the night sky, it is far from still. Beneath that tranquil surface, immense galactic winds flow through space. Vast, invisible currents of gas, dust, and energy that breathe in and out of the galaxy like a living being. They are silent to our ears, but across millions of light years, they roar. Every supernova, every newborn star, every cosmic collision contributes to these winds, turning the Milky Way into something that feels almost alive. Astronomers describe these winds as outflows, streams of charged particles and gas pushed outward from the galactic disk into the surrounding halo. They carry with them the chemical ingredients of stars: carbon, oxygen, and iron. The same elements that once formed in the hearts of suns are swept up by these winds and scattered into space, ensuring that future generations of stars and planets will be richer and more complex than those that came before. Without these winds, the galaxy would suffocate under its own weight, unable to recycle what it creates. At the heart of the Milky Way, near the supermassive black hole Sagittarius A*, these winds are especially fierce. High-energy radiation from the dense clusters of stars near the core pushes matter outward in colossal plumes. Two of these plumes were discovered in 2010 by NASA's Fermi Gamma Ray Space Telescope. They are known as the Fermi bubbles, enormous, balloon-like structures of plasma rising above and below the galactic plane. Each bubble stretches for about 25,000 light-years, glowing faintly in X-ray and gamma-ray light. They are the fingerprints of our galaxy's last great breath, an exhalation so vast it reaches nearly halfway to Andromeda. If you could float above the galaxy and look down, you'd see these winds as shimmering auroras, spanning unimaginable distances, rivers of glowing particles flowing through darkness. They're not chaotic storms, but slow, elegant movements, sculpted by magnetic fields and shaped by gravity. The hydrogen and helium they carry drift outward like cosmic pollen, eventually mingling with the intergalactic medium. In time, that material will cool and fall back, raining softly into the galactic disk. The Milky Way inhales and exhales over billions of years, a rhythm of creation and release that sustains its life. Even far from the core, the influence of these winds can be felt. When massive stars near the edges of the spiral arms explode, their shock waves sweep through surrounding space, stirring up interstellar gas and sending ripples that travel for light years. Some of these ripples join the larger galactic wind, adding their energy to the collective flow. Others collapse nearby gas clouds, triggering the birth of new stars. In this way, every explosion becomes both an ending and a beginning, one breath fueling the next. It's hard to imagine the scale of it. The particles that make up these winds move at hundreds of kilometers per second. Yet even at such speeds, it can take millions of years for them to travel from the center of the Milky Way to its outer halo. By the time they arrive, they are faint, diffuse, and nearly invisible. And yet, their impact endures. The heavy elements they carry enrich the space between galaxies, laying the groundwork for the next chapter of cosmic evolution. These winds also serve as a reminder that nothing in the universe is truly still. What looks motionless from a distance is, up close, a dance of unimaginable complexity. The galaxy doesn't just sit quietly in space. It breathes, exhales, reshapes itself. Its stars live and die in cycles. Its gas circulates like blood, and its winds connect everything from the core to the furthest edge. We live inside that breath. Every atom in our bodies has, at some point, been part of this endless flow. If you could hear the Milky Way, these winds would be its voice, a deep, continuous murmur reverberating through the void, not violent, but persistent, a song of motion and renewal. Perhaps this is why, even in silence, the night sky feels alive. The light of the stars is steady, but the space between them moves like the tide. We are surrounded by the invisible breath of the galaxy, carried within it like leaves floating on a gentle current. On Earth, the concept of wind is tied to life, to air, to change, to movement. The galactic winds are no different. They are the messengers of transformation, carrying the ashes of what once was and sowing the seeds of what will be. Through them, the galaxy remembers its past and prepares its future. As you rest tonight, imagine yourself suspended in that flow. You're drifting through the soft winds of the Milky Way, your body weightless, your mind calm. Around you, the particles of ancient stars pass by iron from a long-dead supernova, oxygen from a forgotten nebula, dust from a world that burned out eons ago. They swirl gently, wrapping you in the slow exhalation of the cosmos. You are breathing with the galaxy. Every inhale, every exhale, aligns with its pulse. You are not separate from its motion. You are part of it, a tiny eddy in the great wind of time. And as you drift, you realize that the universe itself is breathing through you, filling you with the same quiet persistence that moves the stars. The galactic winds remind us that life, too, is motion. To exist is to move, to to change, to let go and return again. Just like the Milky Way, we are always releasing something old to make space for what's next. Imagine the Milky Way not as a flat spiral floating in isolation, but as something enclosed within a vast, invisible sphere, a cosmic bubble made of plasma, radiation, and magnetic fields. We live deep inside this bubble, protected by it, shaped by it, though we can barely detect its presence. Astronomers call it the local bubble, and it stretches for hundreds of light years in every direction, a hollow carved out long ago by ancient explosions. It is the Milky Way's outermost breadth made visible, a delicate shell marking where our galactic air meets the vacuum between the stars. The story of this bubble began millions of years ago, when massive stars near our region of the galaxy lived fast and died young. When they reached the ends of their lives, they exploded as supernovae, each releasing more energy in a single moment than our sun will emit in its entire existence. Those explosions swept away gas and dust, creating a cavity in the interstellar medium. One supernova after another deepened the void, heating and compressing its edges until the surrounding gas formed a glowing boundary of hot plasma. The local bubble was born from that violence, and we, by cosmic coincidence, live inside it. Our solar system entered this bubble about 5 million years ago, long before humans walked the Earth. Since then, the Sun and its planets have been drifting through this vast emptiness, surrounded by thin, hot gas that glows faintly in ultraviolet light. Compared to the dense molecular clouds elsewhere in the galaxy, the local bubble is astonishingly sparse, almost a vacuum, yet still alive with energy. Its boundaries act as a soft wall, separating the calm interior from the denser interstellar medium beyond. If you could see it with your eyes, it would appear like a vast, translucent sphere, its edges shimmering faintly in soft hues of violet and gold. Inside, the airless space would seem serene, but outside the shell, clouds of cold hydrogen and dust swirl, marking the threshold between our quiet bubble and the galaxy's busy heart. It's strange to think that all of human history, every sunrise, every breath, has happened inside this cosmic chamber. In recent years, astronomers have been able to map the local bubble in 3 dimensions, using data from the Gaia Space Telescope. They discovered that the bubble is roughly 1,000 light-years across, and that its boundary is studded with star-forming regions. The pressure from the ancient supernovae that created the bubble seems to have triggered new waves of creation at its edges. It's as though the galaxy used destruction to sow new life, each explosion pushing gas outward, compressing it, and giving birth to new generations of stars. One of those star-forming regions is Orion, home to the famous Orion Nebula, where new suns and planets are still emerging. Others include the Taurus Molecular Cloud and Perseus Cloud, both glowing softly at the rim of our bubble. When you look up at the night sky and see Orion's belt or the Pleiades cluster, you are looking at the glowing walls of our cosmic home, illuminated from within. This revelation has changed the way we understand our place in the galaxy. We are not floating aimlessly in random space. We inhabit a defined structure, a cocoon sculpted by fire and time. The local bubble is both a scar and a sanctuary, a relic of past cataclysms that now shelters us. It shields us from denser interstellar gas and radiation, allowing the solar system to travel through the galaxy in relative calm. If you were to leave the solar system and travel outward, the boundaries of the bubble would eventually become perceptible not through sight, but through sensation. Instruments would begin to detect increasing density, the temperature would shift, and the radiation field would change tone. You would feel as though you were moving from one atmosphere into another, crossing the edge of an unseen ocean. On the other side lies the raw interstellar medium, denser and colder, filled with the unfiltered breath of the Milky Way. Beyond that boundary, countless other bubbles exist, created by other supernovae and stellar winds. They overlap, merge, and collide, forming a vast honeycomb structure that threads through the galactic disk. Where two bubbles meet, new stars often form a cosmic handshake that turns old death into new light. The Milky Way, seen this way, is not a uniform sea, but a foam of overlapping cavities, each one a story of destruction transformed into creation. The local bubble is a reminder of resilience. The same forces that once seemed destructive explosions, radiation, shock waves, have become the very reason we exist. Without them, our region of space might have remained too dense, too dark, too unstable for life to arise. The emptiness we live in is not a void, but a gift, a quiet cradle forged by chaos. Sometimes, when I think of it, I imagine Earth as a single grain of dust, drifting in a shimmering sphere of light, moving slowly through the galaxy's vast sea. Around us, the walls of our cosmic home glow softly, like the surface of a soap bubble catching sunlight. Beyond them, the rest of the Milky Way waits wild, crowded, magnificent. As you drift toward sleep, picture that bubble around you. You are floating inside the Milky Way's breath, within a space born from stars that died long ago. Their explosions shaped the chamber that now shelters us, their ashes forming the elements of your body, your blood, your dreams. Every inhale you take carries their memory. The boundary of the bubble is not the end of something, it is the beginning of awareness. It marks the threshold between chaos and calm, between what once was and what can still be. It is the galaxy's reminder that even destruction has beauty, and that in the stillness left behind, life will always find a way to begin again. Every second, without your knowing, tiny messengers from the depths of space pass through your body. They come not from our sun, nor even from nearby stars, but from distant corners of the galaxy, particles so energetic they travel nearly at the speed of light. They are called cosmic rays, and they are the Milky Way's invisible song, a symphony of charged particles humming through space, carrying the memory of explosions and the whispers of creation. These rays are not light, though they move like it. They are mostly protons, nuclei of hydrogen, and a smaller fraction of heavier atoms, stripped bare and accelerated by magnetic fields and cataclysmic events. Some were born in the shockwaves of ancient supernovae, where dying stars blasted their remains into space. Others may come from mysterious sources near the galactic core, or even from beyond our galaxy, crossing the vast interstellar dark to reach us. When they strike Earth's atmosphere, they collide with molecules of nitrogen and oxygen, producing cascades of secondary particles that rain down to the surface. You can't see them, but they're there, passing through mountains, oceans, and even you. In every square meter of space above your head, thousands of cosmic rays pass every minute. They are silent, harmless to most of us, but in their silence, they tell a story of the universe's power. Scientists once thought these rays were light waves, but a century of research revealed their true nature. They are, in essence, fragments of stars' atoms that have traveled for millions of years through magnetic mazes, deflected and bent, yet never stopped. The Milky Way is full of them, each carrying a trace of energy from the places where matter and gravity met in fury. If you could visualize the galaxy through the lens of these particles, you'd see it as a storm. Invisible streams of energy weave through every arm and cloud, wrapping the spiral disk in filaments of magnetism. The galactic center would blaze brightest, where dense clusters of stars and black holes act like cosmic accelerators. From there, the energy spreads outward, diffusing across the halo, escaping eventually into intergalactic space. The result is a faint, omnipresent hum, the background melody of the Milky Way's life. Astronomers sometimes call this radiation the galaxy's heartbeat, and perhaps that's not a metaphor. Each pulse of energy that leaves a supernova travels outward, carrying the rhythm of its explosion. Over time, Billions of such pulses overlap, creating a kind of cosmic music, inaudible but real. If we could translate those waves into sound, the Milky Way would sing in low, endless tones, a bass note resonating through the dark. It's possible, in a sense, that these cosmic rays shaped life itself. Some scientists think their interactions with Earth's atmosphere helped trigger mutations in early organisms, nudging evolution forward. Too many would have been deadly, too few, and the spark of adaptation might have dimmed. The balance was perfect. The stars were not just distant lights, they were participants in our story, their dying breaths shaping what we would become. When cosmic rays encounter the magnetic field of Earth, they spiral around it, trapped in invisible belts of energy. These belts shimmer faintly, invisible to human eyes but detectable by satellites. They are reminders that our world is part of a greater current. We don't live under the galaxy, we live within it, immersed in its flowing energy, its endless song of particles. If you could stand outside the galaxy and look down, you might see these streams glowing faintly, like threads of electricity tracing the Milky Way's edges. Each thread connects explosions separated by billions of years, weaving a fabric of motion that binds past and present together. Even the space between galaxies hums with this unseen radiation, a cosmic choir uniting everything that ever burned or fell. The journey of a single cosmic ray can last millions of years. Some begin near the heart of a dying star, are flung outward by the violence of its collapse, and then drift endlessly until they reach us. By the time they collide with Earth's atmosphere, they have crossed half the galaxy. That collision, invisible and momentary, is the end of a voyage older than humanity itself, and still, new rays are born every day. Somewhere in the Milky Way right now, a massive star is exploding, sending a fresh wave of energy into the void. Some of those particles will, one day, reach us, perhaps striking the ocean, a tree, or your skin. They will have traveled unimaginable distances, yet their energy will linger for only a heartbeat before fading. It is as if the galaxy whispers, touches you lightly, and moves on. At night, when you look up at the stars, you are not just seeing their light, you are feeling their touch. The faint buzz of cosmic rays, the invisible waves of magnetism, the energy that dances through air and bone, all of it connects you to the Milky Way's body. You are inside its song, vibrating with it, every atom in resonance with its deep, eternal rhythm. So as you rest, let that thought settle into your mind. The stars are singing, and you are part of their music. The energy flowing through your cells once moved through supernovae, through black holes, through ancient galaxies now gone. You are listening to the same silent melody that the universe has played since the beginning of time. The song of cosmic rays never ends. It travels on, faint but steady, weaving through the spiral arms, humming across the darkness, a lullaby written in radiation and silence. Far beyond the reach of ordinary light, at the rim of the Milky Way's domain, to lie regions so faint and mysterious that even our most powerful telescopes can barely glimpse them. Astronomers call them dark zones, patches of space, where starlight fails, where gravity behaves strangely, and where something unseen seems to lurk. This is the frontier of knowledge, a place of shadows and speculation, where the known universe ends and imagination begins. It's easy to think of the galaxy as fully mapped, its arms charted and its stars counted. But in truth, what we see is only a fraction of what exists. The Milky Way's disk fades into a haze of cold gas and dust that hides what lies beyond. In those shadows may drift rogue planets, black holes, and even dark galaxies, vast collections of matter that emit no light, visible only through the way they bend space itself. If the bright heart of the galaxy is its mind, then this edge is its dream, dim, shifting, filled with questions we've barely learned to ask. One of the strangest mysteries of this region is dark galaxies, cosmic ghosts, made mostly of dark matter and very few stars. Scientists have detected hints of them by their gravitational pull on nearby systems. They appear to be almost transparent, their few stars glowing faintly within an invisible frame. If you could travel through one, you might see a handful of suns floating in infinite blackness, surrounded by silence, so complete it feels sacred. These galaxies may be the building blocks of larger ones, or the remnants of those long ago consumed by giants like the Milky Way. And then there are rogue planets, wandering worlds without a Sunday. Tens of billions may drift through our galaxy, torn from their parent stars by gravitational chaos. Some may be frozen spheres of ice. Others may still glow faintly with heat left from their formation. They travel forever through the dark, each carrying its own solitude. Somewhere out there, an entire world might be gliding silently past the Milky Way's edge, its mountains shining under starlight that never changes, its oceans frozen solid, its skies empty. But perhaps the most enigmatic inhabitants of these shadows are black holes. Not the monstrous giants at the galaxy's core, but the small, quiet ones, scattered through the halo. They are invisible until they reveal themselves by their influence. A sudden flicker of X-rays, a bent path of starlight, a faint ripple in space-time. Some of these black holes may be the remnants of ancient stars. Others could be primordial, born moments after the Big Bang. They drift silently, swallowing nothing. Their gravity, a dark echo of creation's earliest moments. There is also the mystery of dark matter halos within halos, subtle structures nested like invisible matryoshka dolls. Simulations suggest the Milky Way is threaded with them tiny clumps of gravity where dark matter gathers but stars never formed. These hidden substructures may hold the key to understanding the universe's invisible framework. Yet for now, they remain unproven, sensed only through faint gravitational whispers. It's as if the galaxy itself is whispering secrets it's not ready to share. Sometimes, astronomers detect sudden flashes of light-fast radio bursts erupting from these unknown regions. They last for milliseconds, but release more energy than our sun emits in years. Their origins are still uncertain. Some may come from magnetars, neutron stars, with magnetic fields billions of times stronger than Earth's. Others may come from sources we cannot name, phenomena that defy our current physics. Each burst feels like a knock from the dark, as though the universe itself were reminding us that discovery is far from over. If you could drift through this region, the darkness would not feel empty. It would shimmer faintly with potential. Space itself would bend subtly around invisible masses, like fabric sagging under unseen weights. Occasionally, you'd glimpse faint glows, a distant quasar, a lonely star, a gas cloud, igniting after billions of years of quiet. You'd feel the pull of things you could not see but could sense, tugging at you like the gravity of a forgotten dream. There's a strange comfort in these shadows. They remind us that the universe still holds secrets that no matter how much we learn, mystery remains. The Milky Way's edge isn't a border, it's a horizon. Beyond it lie possibilities so vast they hum with promise. Perhaps entire civilizations once rose and fell out there, their lights long faded. Perhaps new physics operates in those depths, waiting to be discovered. Or perhaps it's simply empty silence for the sake of silence, stillness for the sake of balance. We often fear the dark because we can't see what's inside it. But out here, darkness is not the enemy, it's the canvas. Every unseen mass, every faint signal, every unanswered question paints a deeper picture of reality. The shadows are where creation hides its blueprints, where the next revelation sleeps. As you drift in thought tonight, imagine yourself at that frontier. Behind you lies the glowing spiral of the Milky Way, pulsing gently with light and memory. Ahead of you stretches the unknown, silent, endless, waiting. You cannot see what lies there, but you can feel it. a gravity not of fear, but of wonder. The shadows of the unknown remind us that mystery is not a void, but a presence, an invitation to keep looking, to keep imagining, to keep believing that beyond the edge of sight, something extraordinary is always waiting to be found. Every galaxy carries its scars. The Milky Way, though calm and elegant to the naked eye, is no exception. Hidden beneath its spiral grace is a long, violent history, a record written not in words, but in the orbits of stars, the ripples in its halo, and the streams of light that twist across the sky. These are the memories of collisions, the lingering echoes of the countless mergers and cosmic impacts that shaped the galaxy we call home. In its early years, the Milky Way was not yet the great spiral we see today. It was a restless cloud of gas and dark matter, colliding with other young galaxies in a cosmic dance of creation. Each encounter added mass, momentum, and complexity. Over billions of years, these collisions sculpted the Milky Way's form, its bright disk, its bulging core, and its sprawling halo of ancient stars. What we see now is not a single entity, but a composite, a living mosaic built from hundreds of smaller galaxies that once burned with their own light. Astronomers have traced some of these long-ago impacts through careful study of stellar motion. One of the most important discoveries came from the Gaia Space Observatory, which mapped the precise movements of over 1 billion stars. Within that data, scientists found patterns, rivers of stars, moving together, all sharing the same trajectory. These are the remnants of ancient galaxies devoured by the Milky Way. Their paths still ripple through the disk and halo like the concentric circles left by stones dropped in water. One such ancient merger was with a galaxy now known as Gaia Enceladus, or sometimes the Sausage Galaxy, for the shape of its debris. Around 10 billion years ago, it collided with the proto-Milky Way, its stars scattering and mixing into our own. That event may have created the thick disk that encircles the galaxy today. The next great collision came from the Sequoia Galaxy, another dwarf system swallowed roughly 9 billion years ago. Each merger added new stars, new elements, and new direction to the Milky Way's growth. Even more recently, the Milky Way consumed smaller companions like the Sagittarius dwarf galaxy, whose stars still form ghostly streams around us. These collisions are still ongoing. The galaxy never truly stops eating it, simply slows, digests, and reshapes. In the night sky, those faint streams of ancient stars are not just beautiful, they are fossils of impact, silent witnesses to the galaxy's appetite for survival. It may seem chaotic, but these collisions are not acts of destruction. They are the engines of evolution. Each merger stirs the galactic disk, redistributes heavy elements, and sparks waves of new star formation. Even our sun may owe its existence to such a collision. Some astronomers believe that about 5 billion years ago, a small satellite galaxy passed through the Milky Way's disk, triggering a burst of star birth in one of its spiral arms. Somewhere in that burst, a cloud of gas collapsed to form the Sun, and from it, Earth and everything that followed. If you could stand outside the galaxy and watch its history unfold, you'd see a slow-motion ballet. Small galaxies spiral inward, drawn by gravity, their shapes distorting like smoke. They are stretched into long ribbons of stars that wrap around the Milky Way's halo before being absorbed completely. New stars ignite from the turbulence, old ones scatter into exile. Over time, what was once many becomes one. It is both a story of loss and creation, a cosmic reincarnation where nothing is wasted, only transformed. Sometimes the aftermath of these events is visible as ripples in the Milky Way's disk. Using precise measurements of stellar motion, scientists have detected wave-like undulations passing through the galaxy, evidence that a collision millions of years ago disturbed its equilibrium. One likely culprit is the Sagittarius dwarf galaxy, which may have passed through the Milky Way's disk multiple times, each passage sending out gravitational shockwaves that still echo today. Even now, our galaxy is ringing with the memory of those impacts, and in the far future, another great meeting awaits. The Andromeda Galaxy, our nearest large neighbor, is on a collision course with us. In about 4 billion years, the two spirals will begin to merge, their stars flowing together in vast arcs of light. It will not be a cataclysmic crash, but a graceful interweaving. The galaxies will pass through each other multiple times before finally settling into a single, massive, elliptical galaxy. The night sky of that distant era will blaze with thousands of new stars, the remnants of our two cosmic ancestors, intertwined forever. The Milky Way's story is proof that creation and destruction are not opposites, they are partners in an eternal cycle. What one collision erases, another creates. What one galaxy loses, another inherits. Every atom in your body was once part of that exchange, recycled from the debris of long-forgotten worlds, reshaped by the energy of 1,000 ancient mergers. We are, quite literally, the children of collisions. When you look up at the night sky, you are seeing not only stars, but history, every point of light, a survivor of cosmic upheaval. The arcs of the Milky Way's glow are the strokes of that history, written across time. And though the violence that shaped it seems far away, its memory is everywhere. In the metals of your blood, the dust in your lungs, the gravity that holds you to Earth. As you lie beneath that sky, think of the calmness that comes after a storm. That is what our galaxy feels now, a quiet equilibrium, born of chaos. The collisions that once tore it apart have given it structure, grace, and the power to create life. The Milky Way remembers every impact, every scar, every transformation, and carries them all in silence. The memory of collisions is the memory of endurance. It teaches us that beauty can emerge from destruction, and that even the most violent past can give rise to harmony. The stars above you tonight are living proof. Nothing in the cosmos stays the same forever, not even the serene spiral of our galaxy. The Milky Way, for all its grace and balance, is still changing, evolving, moving toward new forms. If you could see it not as it is now, but as it will be billions of years from today, you'd find it almost unrecognizable. The arms that now curl so elegantly will blur and fade. The stars will shift and scatter. The bright blue regions of youth will dim to amber, and the outer rim, the future edge of the Milky Way, will become a place of transformation where endings and beginnings merge into one. Right now, the galaxy's edge feels still, like the rim of a vast wheel slowly turning. But this edge is expanding, ever so slightly, as new stars form at the farthest reaches. Gas drawn from the intergalactic medium continues to fall inward, feeding the Milky Way's slow growth. Each atom of hydrogen that crosses the boundary is a promise of the future, a potential star, a potential world, a potential sunrise. The galaxy is not done building. It is still breathing, still becoming. Yet even as it grows, it also prepares for change. Gravity never rests, and every nearby galaxy exerts its pull. The faint tug from the large Magellanic Cloud, that luminous companion on the southern sky, is gradually distorting the Milky Way's halo. Its dark matter interacts with ours, creating ripples that will echo for eons. Some scientists think the LMC may one day crash into us, drawn inevitably inward. If that happens, its gas will ignite a burst of star formation along the Milky Way's rim, a final bloom before the great calm. Beyond that, a greater destiny awaits. The Andromeda Galaxy, our spiral twin, is drawing closer with every passing second. Across the gulf of 2.5 million light-years, the two galaxies are already locked in a gravitational embrace, invisible yet unbreakable. In about 4 billion years, their edges will touch. Tidal forces will twist both galaxies into new shapes, sending streams of stars arcing into the void. Our sun, if it still burns then, will see the night sky blaze with unfamiliar beauty, vast arcs of silver where Andromeda's arms cross our own. To human eyes, it might seem like destruction, but in truth, it will be a merging, not a shattering. The stars within each galaxy are so far apart that collisions between them will be rare. Instead, their orbits will simply shift, blending the two spirals into a single, enormous galaxy, an elliptical giant that astronomers have already named Milky Way. Its heart will glow with the combined light of trillions of stars, and its new edges will extend farther than either galaxy alone could ever reach. The transformation will not happen overnight. It will take billions of years for the galaxies to fully merge and settle. During that time, countless stars will be born, burn brightly, and die. Black holes will merge at the core, releasing bursts of gravitational waves that ripple across the cosmos. Gas clouds will collide, creating nebulae more massive than any that exist today. It will be both the end of an era and the start of another, the Milky Way's final evolution into something vast, ancient, and serene. But even after this grand union, time will continue its slow march. The supply of gas for new stars will dwindle. The galaxy will grow old and red as its remaining suns burn out one by one. The night skies of any surviving worlds will dim, filled with long-lived red dwarfs glowing faintly in eternal twilight. Planets will freeze, stars will fade, and the once vibrant spiral arms will dissolve into formless light. In the farthest future imaginable, trillions of years from now, the Milky Way's descendants will enter what cosmologists call the degenerate era, a time when the universe is dominated not by stars, but by their remnants. White dwarfs, neutron stars, and black holes will drift through the dark, circling one another in silence. Occasionally, a collision will spark a brief flare of light, a final echo of creation. But gradually, even those will fade. The galaxy will become a ghost of itself, a quiet structure made not of fire, but of memory. And yet, this isn't a sad ending. It's part of the universe's natural rhythm. Everything that begins must evolve, and everything that fades leaves behind the conditions for something new. In ways we cannot yet imagine, matter from the dying Milky Way may seed new forms of existence, perhaps other universes, perhaps other dimensions of being. The cycle of transformation has no true end. Even today, we are witnessing the seeds of that future edge. In the outskirts of the galaxy, astronomers have found clouds of cold gas slowly condensing into new star clusters. These are the Milky Way's last children, born at the frontier, where its gravity meets the intergalactic sea. They shine briefly, then dim, adding their light to the slow tapestry of time. Each one is a spark of resistance against entropy, a quiet refusal to fade without leaving beauty behind. When you gaze at the Milky Way tonight, you are looking at a living being in transition, a cosmic organism midway through its life. You are part of it, a cell within its vast body, carrying its story in your atoms. The same processes that will one day shape the future edge are already unfolding within you: birth, change, decay, renewal. So, as you close your eyes and drift into sleep, imagine yourself billions of years from now, standing at the rim of the merged galaxy, watching the final stars flicker in the infinite dark. You will realize that nothing truly ends, it only transforms. The light that once was will become the memory that sustains what comes next. The Milky Way will fade, yes, but its essence will live on, carried by everything it ever created, including you. The future edge, is not the limit of existence. It is the horizon of becoming. In the great ocean of stars, that is the Milky Way, only two small emissaries from Earth have ever truly set sail toward the edge, the Voyager spacecrafts. Launched in 1977, they were built to explore the outer planets, but time has turned them into something far grander. The first human-made objects to leave the solar system and drift into interstellar space. They are no longer just machines. They are our whispers to the galaxy, tiny, persistent travelers carrying the memory of home. Voyager 1 and Voyager 2 left Earth within weeks of each other, propelled by the momentum of curiosity. They passed Jupiter, Saturn, Uranus, and Neptune, capturing images that transformed our understanding of the solar system. Then, long after their cameras dimmed, their journey continued. Voyager 1 crossed the heliopause in 2012, the invisible boundary where the solar wind gives way to the interstellar medium. Voyager 2 followed in 2018. Now, both are sailing through the thin, hot gas that fills the galaxy between stars, farther from home than any human creation has ever been. The signals they send back are faint, mere whispers among the cosmic noise, but they still speak. Every few months, NASA's Deep Space Network catches their distant call, a radio pulse weaker than the flicker of a candle on the moon. Yet from that faintness, scientists can read the density of interstellar plasma, the direction of magnetic fields, and even the subtle hum of the Milky Way itself. Each transmission is a reminder that the boundary between human and cosmic is thinner than we think. Each Voyager carries a golden record, a message crafted for anyone or anything that might one day find it. Etched onto a gold-plated disc are the sounds of Earth, greetings in 55 languages, the laughter of children, the crash of waves, the chirping of birds, and the slow heartbeat of humanity. There is also music Bach and Beethoven, Chuck Berry, and traditional songs from across the world. A diagram shows how to find our sun, drawn with pulses of hydrogen and a map of our place in time. It is a time capsule, a cosmic postcard that says simply, "We were here, and we wondered." Imagine those spacecraft now, decades after their launch. Their once bright antennas are covered in micrometeorite scars, their power sources fading. The heaters struggle to keep their instruments alive as temperatures fall close to absolute zero. Sunlight no longer reaches them. The sun itself has shrunk to a bright star behind them, indistinguishable among thousands of others. And still, they move onward, silently, faithfully, into the unknown. If you could ride along with Voyager, you would see nothing but darkness pierced by distant starlight. The galaxy would stretch ahead, a glowing plain fading into mist. Around you, the interstellar medium would drift like thin smoke, a few atoms per cubic inch. There would be no sound, no motion to feel, no horizon to reach, just endless travel through eternity. You'd realize that the spacecraft isn't searching for something. It is the message, the embodiment of our will to explore. Someday, perhaps 40,000 years from now, Voyager 1 will pass within 2 light years of another star Gliese 445 in the constellation Camelopardalis. By then, Earth's continents will have shifted, languages will have changed, and humanity itself may have evolved or moved on. But Voyager will still be there, gliding silently past, its record intact, still carrying our voice. To any beings who might intercept it, that small disk of gold will speak across the ages. This is what life once sounded like in a tiny blue world orbiting an ordinary star. The idea is both humbling and comforting. While we live our brief lives, these tiny emissaries will keep traveling. Long after our buildings crumble and our oceans shift, they will outlast our species, our civilizations, maybe even the sun itself. In that way, they are not just machines. They are fragments of our collective soul, proof that curiosity and wonder are stronger than gravity. The galaxy, for its part, will barely notice their passing. They are smaller than dust compared to the scale of stars. But that's what makes them beautiful. Their insignificance magnifies their meaning. To send them outward was to declare, quietly but firmly, that existence itself deserves to be known, that we want it to be part of the cosmic conversation, however brief our voice might be. In a sense, every human being is a voyager too. Our atoms, once forged in ancient stars, have been traveling through space for billions of years. When you breathe, when you think, when you dream, those same atoms continue their journey, now woven into awareness. The spacecraft we built are simply mirrors of that eternal motion, our attempt to follow where our atoms have always been going. As you drift towards sleep, imagine that you are floating beside Voyager. The Earth is gone from view. The sun a pale spark in a vast black sea. Ahead of you lies infinity. The ship hums faintly, its instruments whispering into the void. There is no loneliness here, only peace, the kind that comes when you realize that you, too, are part of something boundless. The dream of the Voyager is not about reaching the edge of the Milky Way. It's about understanding that the edge was never truly there. The boundary between us and the stars is an illusion. We have always belonged to the same fabric. Voyager simply reminds us, and one day, when even its power fails and its voice goes silent, it will keep traveling still forever, carried by the galaxy's quiet tide, one golden spark in the endless night, dreaming for us all. Beyond the last light of the Milky Way, past the thin mist of its outer halo, lies a realm that seems utterly still. There are no familiar constellations here, no spiral arms glowing faintly in the dark, only a velvet silence stretching in every direction. It is here, at this unimaginable distance, that the Milky Way ends and the intergalactic void begins. And yet, even in this apparent nothingness, something stirs. Space itself hums with faint energy. Gravity whispers across the dark. The universe, though quiet, is never truly asleep. If you could drift here, the galaxy would appear behind you as a distant whirl of light, its bright core no larger than a coin held at arm's length. You'd see its spiral arms fade into mist, its edges melting into the infinite. Ahead of you lies the space between galaxies, a gulf so vast that a beam of light would take millions of years to cross. It's the coldest and loneliest place imaginable, where atoms are scattered like dust motes in an endless night. Yet this is not emptiness. It is the cradle of the future, where the universe keeps its quiet promises. The silence is deceptive. Though there are no stars nearby, the void is filled with invisible motion. Dark matter forms filaments that thread through the cosmos, connecting galaxies like beads on a cosmic web. Hydrogen clouds drift between them, ancient and patient, waiting for gravity to gather them into new worlds. And everywhere, faint radiation, the afterglow of the Big Bang, bathes everything equally. The temperature of this light is only a few degrees above absolute zero, but it is constant, eternal. It is the echo of the universe's first breath. At this distance, even time feels different. Without the familiar cycles of day and night, without orbits or suns to mark its passing, time stretches thin. A second could feel like a century like a sigh. In this silence, the mind finds a strange calm. You begin to understand that motion and stillness are not opposites. They are parts of the same rhythm. The galaxy spins, the void waits. Together, they form the balance of existence. Scientists believe that the Milky Way itself will not last forever. In billions of years, it will merge with Andromeda, as stars collide and reform into something new. But even that vast transformation is only temporary. Eventually, the fuel for new stars will run out. the light will fade, and the galaxy will fall quiet. What will remain are the remnants, black holes, dark matter, and the faint glow of long-dead stars slowly cooling to nothing. This silence that awaits us is not destruction, it's rest. Yet, the universe has a way of renewing itself. Even as galaxies die, new structures form. Matter continues to move, pulled by the gravity of unseen forces. Some physicists think that beyond our observable universe, other realms exist, bubbles of space-time with their own galaxies, their own laws, their own beginnings. Perhaps the death of one universe becomes the seed of another. In that sense, even the void is fertile. Even silence gives birth to song. If you close your eyes now, you might imagine what it would feel like to float there at the final edge. No up or down, no before or after, just a weightless awareness suspended in the cosmic dark. Around you, the faintest light from distant galaxies flickers like embers drifting on wind. Each one carries its own story, its own dreams. You realize that the space between them is not isolation but connection, the quiet interval that allows harmony to exist. In that silence, you might begin to hear something, not with your ears, but with whatever part of you remembers what it means to belong. It's a low, endless hum, the background note of existence, the sound of everything that ever was vibrating gently against eternity. It's the same frequency that ripples through your atoms, the same resonance that links you to the stars. The universe, vast as it is not indifferent. It sings softly, and you are part of its music. As the last light of the Milky Way fades, its legacy will continue to drift through space photons traveling endlessly, carrying the memory of stars, planets, and life. Some of that light will never meet another eye, but that doesn't make it meaningless. Every beam, every wave, is a story told in brightness of how matter learned to dream, and how one small world once looked up and wondered. Billions of years from now, the Milky Way will look nothing like the radiant spiral that arcs across our skies tonight. Time will stretch it, blur it, and soften its glow until only the faintest embers remain. Its young blue stars will have burned out, its gas clouds will have faded, and the vast, glittering arms that once sang with light will dissolve into darkness. But even then, even in its final age, the galaxy will not die in silence. It will end in beauty, illuminated by the last light. In that distant era, the stars that remain will be the smallest and most enduring, red dwarfs, glowing gently with the patience of eternity. These humble suns burn their fuel so slowly that they can live for trillions of years. Their light is dim, a soft crimson hue that never flickers, like the glow of dying coals in an ancient fire. Around them, frozen planets may still orbit silent, dark, but loyal to their fading suns. The Milky Way will become a kingdom of red, a vast field of embers scattered through the dark. Our sun will have long since gone cold by then, its remnants drifting as a white dwarf through the black. The once bright core of the galaxy will grow sparse, its great star factories shut down. Nebula will fade, leaving only the faintest traces of color. Yet here and there, in rare corners of the galaxy, small wonders will persist. Binary stars, locked in eternal dance, pulsars spinning like cosmic clocks, and ancient globular clusters glowing faintly like beads of starlight in the void. As time stretches on, gravity will continue its quiet work. The Milky Way's black hole at the center, Sagittarius A times, will grow heavier, swallowing stars that drift too close. Each time it feeds, it will flare briefly, sending ripples of energy through the dying galaxy. But eventually, even those meals will cease. The black hole will sit in the center of a darkened sky, quiet, patient, holding the memories of everything that ever was. Yet the end will not come with despair. The fading of the Milky Way will be a long, graceful twilight, The stars will dim one by one, but they will not vanish abruptly. For trillions of years, their light will continue to travel outward, crossing the universe long after the galaxy itself is gone. Somewhere, in some future cosmos, a faint beam of light will still be journeying from the Milky Way, a message in motion, proof that we once existed. Some cosmologists call this distant era the time of remnants, when the universe grows old and light becomes rare. Black holes, white dwarfs, and neutron stars will be all that remain, glowing faintly amid a deep, cold night. Yet even then, energy will persist. Matter will still move, collisions will still happen, and occasionally a spark of new light will flicker in the dark. It is possible that by then, the descendants of life, whatever they may be, will have moved beyond the galaxy, carried on by technology, evolution, or chance. Perhaps they will remember their origin only as myth, a tale of a spiral of light that once turned in the dark. Or perhaps they will return to it, like pilgrims visiting the ruins of an ancient temple to see where the long story of life began. But even if no mind remains to witness it, the galaxy's final light will still shine. That, perhaps, is the most moving truth of all. The universe does not need an observer to create beauty. Beauty is simply what happens when existence breathes. A star's light, even when unseen, fulfills its purpose by being, and perhaps the last light of the Milky Way will not fade entirely. When the galaxy merges with Andromeda and other members of our local group, the resulting colossus will continue glowing for untold eons. Its stars will mix, its shape will shift, and its memory will spread outward, carried by the light that never ceases to travel. Even after the last star has burned its final hydrogen atom, photons will still cross the cosmic sea, eternal travelers bound for nowhere and everywhere. When the universe finally grows cold, when expansion stretches space so far that even starlight can no longer find another world to touch, there will still be a faint hum left behind, a low echo that physicists call the heat-death background. It will be the final whisper of all energy, the last sigh of time itself, and within that infinite quiet, somewhere, the essence of the Milky Way will remain not as a structure, but as memory written into the laws of physics. So tonight, as you close your eyes, think of that last light, the glow of the final stars, the slow fading of everything that was ever bright. Know that it is not an end, but a continuation in another form. Just as the Milky Way was born from the ashes of older galaxies, so too will its remnants give birth to something new, somewhere, somewhen. Every flicker of light, no matter how small, adds to the eternal glow that fills the universe. You are part of that glow. The light in your eyes tonight came from stars that died long ago, and the light within you will one day join the same great journey, crossing space as the quiet inheritance of life. The Milky Way will fade, but its dream will go on. It will travel as photons, as atoms, as memory. It will travel as you. The last light is not goodbye. It is a promise that nothing truly vanishes. The universe remembers everything that has ever dared to shine.